Hmm? Now, and I'll be in space. So, okay, so now you have, as I said, always follow you have set up your hardware, you've set up your software. What is next? Hmm? So, what okay, you guys all done C, all of that. What is the first test you do when you are coding or when you are learning to code or when you want to test your IDE, right? In terms of software, like C, or whatever. What is the first test you do, right? So that is the basic software test. Print, hello world, right? So what do you think the basic test of an embedded engineer is? Engineers, the future engineers of oh higher, the future engineers of the country, right? Well, I mean, it's normal. It's normal. I mean, in engineering, your lecturers always insult you, right? I mean, or you guys, they don't insult you because okay, perhaps now times have changed, but for our time, they were just insult upon insult because I mean, we were trying to write some exams, and then the man came and then he was going through everybody's work, right? He was going through. Then he said that he pities the future of engineering in Ghana. You see, and I was told that so it's normal. If I insult you, it's normal. I mean, it doesn't take away anything, right? So, what is the basic test of when we are trying to test whether your software and then your hardware is working? What is the basic test you do on this board? You guys have used Uno and Master. You know about edge impulse, and then you don't know about the basic test. So it means that you see that to print something for software is just easy. You are calling a library right now. When you come into the actual hardware domain, right? Because it's so complex, you just print something on an actual hardware like this. You cannot print something and see it on this board, right? So what visible component on this board or a component can you attach to this board and an LED, right? So that easy. Okay, so now the basic thing is the basic thing you can do is to test your an LED, right? First of all, if there's no embedded LED on the board, all you have to do is what? Connect your LED to it, right? Connect one pin. You know the LED has pins, right? Positive and negative or whatever. You connect the positive to one of the pins and connect the negative way. Huh? To the ground, right? And then you are good to go. But this board has an embedded LED, right? So all you need to know is where to locate the embedded LED or the name of the embedded LED. And then you can use that to test. Understood? Okay, so let's just test the LED and go away. I mean, all of these are just basics. I shouldn't be teaching you all these things. Okay, so this my Arduino IDE. It takes some time to open, right? The libraries. It depends. It depends. Probably 250 to probably 400 megabytes. Huh? No, no. I was talking about the main board library, but not the individual libraries. But before you start, you must install the main board. That one it takes time. Yeah, yeah, it's large, and then it is also downloading and installing at the same time. So after it's done, after your 2 3 hours, as I said, it depends on your internet connection too. What? Okay, so now this is this is your the interface of my Arduino IDE, and then I believe yours will be the same, right? So now the basic test is embedded within the IDE, right? All you have to do is what? How many of you have done it before? As I said, I believe some of you have never even held a wire before here. Am I lying? Am I lying? Okay, so you go to you go to file, right? And then you go to examples. Then you see basic. You can see, right? And then the third one. So here the test is known as blink, right? So what you are testing is you're going to blink the LED. Understood? All right. So this is the code. Very very simple, right? Now what you do is you connect the board. As I said, I'm just insulting you guys by doing this. Engineers, pa. Okay, so you connect your board to your PC or whatever you have. I hope it works. I've not used it for a long time. Now, once you see the green light here, what does that mean? Eh? It means that there is power, right? It's on, or there is power flow through it, right? So as easily as that. Now, as I said, on your right or left, whatever, here is the LED. You see up after this one, right? There's an embedded LED on it. So that's what you're going to blink, right? So what you do first of all is that you have to select the board. So once you connect it to it, once you have installed the board library, right? It is supposed to see the board. If it doesn't see it, it means that there's an issue, and then you have to go and reinstall and stuff like that, right? So you come here. Have you seen it? Select. Have you seen select board? Right. You come to select board, and then you just see that you see Arduino Nano 33 BLE. Have you seen it? Yes. And then you see that it is connected to COM5. So the port that it is connected to is 5 on my PC, and that's all, right? So now after you have done this, you just verify, and I mean you know the name of an Arduino code. What is an Arduino code called? I mean, probably objectives or something. You know, we have C. I mean, C code is, how do you call? Okay, it's just C code, right? C++ code and stuff like that. So in Arduino, how do you call the code in Arduino? If you write a code, how do you call it? Anybody? Arduino what? I mean, if it was that easy, I wouldn't say I will bring it in some objectives. Hey, so you guys don't know this one too. It's called a sketch. Arduino sketch, right? Okay, so now after you have done, you verify your sketch. The verify your sketch just means you compile it to see if there are errors or not. Now, depending on your code or depending on your code and then the number of libraries you've called, right, it will take a long time or a very short time, depending on the type of libraries you've called. But because it is a very simple example, once you verify, have you seen the check mark here? That's the verify. You just click on it and then it will begin to verify it for you. And then the verify just is compiling, it's checking for errors, it's checking that everything is okay, right? If there are errors, it will give you um, the errors in the console. If there are no errors, it will say everything is okay, and then you can go ahead and upload, right? So sometimes, depending on code, probably in case you are doing some machine learning, it can take about 5 hours. Yeah, sometimes 2 days. Okay, so you see that once it's done compiling, it will tell you that it's done compiling. And if there are errors, it will give you the errors. Now, one of the most important things here is that the sketch, after it has compiled your Arduino sketch, it will give you what is known as the how much RAM it has used, and then how much flash it has used. So based on, you know that, as I said, the Arduino boards are limited. They have the they have limited RAMs and stuff like that, right? So once you compile your code, it will give you that you are using 8% of the RAM or 100% or more than 100%. And then you know that once it goes above 100%, you cannot run it, anything on it, right? So you need to go back to your code and then remove some stuff to be able to run on it. So here it's saying that I've used 8% of the flash. So first of all, the code will get stored in the flash. You know what? You know why that is, right? Once you write a code, right, and then himself on your normal pieces, once you write a code, it gets stored in the flash, and then once the code starts to run, um, the the intermediate values get stored in the RAM. You guys know that? Yes, no. I mean, if you write a code like probably normal C code, and then you say uh, you say A is equals to 5. Let's say int A is equal to 5. Where do you think that 5 is stored? And where? RAM, flash, eh? RAM. Why isn't it stored in the ROM? So what is stored in the ROM? What is stored in the ROM? So if I write int A is equal to 5, where is the 5 stored? ROM or RAM? And why? Maybe or maybe not. Okay, so here it's telling me that I've used 8% of my flash, and then it also tells you that I'm using 16% of the dynamic memory, which is the RAM, right? And then it tells you the total size. Here it tells you that you have 8983040 bytes of flash, and then you have 262144 bytes of ROM. So based on your program, it means that based on the board you're using, your program must be as simple as possible. In case you are using very low cost board, right? It must be just very simple programs. If you write any complex thing, it wouldn't be able to even bypass this stage, right? Now, once you see that everything is okay, what do you do next? You upload the code onto the board, and then once everything goes well, you will see that the board will begin to blink. The LED on board will begin to blink, right? And then you must know that once you are uploading, it compiles again, but this time it's faster, right? It compiles again, then it uploads the program onto the board, and then it will start to operate. Understood? So it's done. So you can see some yellow light, right? Have you seen the yellow light? So is it that is it blinking? Right. So you see that a very easy test. Though once you are done with this test, then you know that your software is configured properly, your hardware is also okay, and then now you can go back to doing some wild things with it or not. Right? And you see how simple the code is. I believe you guys know how an Arduino code runs, or you guys can explain everything here. So in the exams, what does this mean? What does it mean? Stuff like that. Very, very, very easy. And then you just get your points and then you go away, right? You know, you guys say you have used it before, right? You guys know what the setup means. And I shouldn't go through all this. Just basics. You know that in Arduino we have two functions within an Arduino code, which is mandatory. You must know that. Like how if you write a C, you have a main function, right? Or something like that. Main, right? You have a main function, then you have functions outside it. And then that you can call within the main function, right? In Arduino, there are two functions. Very, very important. Without those two functions, it can't run. Right? One is known as the setup. Have you seen it over there? And then one is known as what? The loop. Two. Only two. So all your codes must enter here. Or if you have some other functions, you can include them. But this is very important. Setup and loop. What do you think the setup do? Very simple questions like this. What does the setup function do in this code? And then you just answer it. Huh? Hurry up, and let's go. Not only the piece. What like okay, let's say in general, what does the setup function do? I mean, this is just English. It's in the name. Yeah, it runs once and then it sets up everything. So if you have some pins, if, in case you're using any pin on the board, right, you have to set it up in the setup function so that it runs once and then it configures everything. So the setup function, once you write any code within the setup function, it runs just once, right? Are you all there? What of the loop? English, simple English. Everybody knows that, right? So the loop means that once you put any code in the loop, it runs forever. So it means that you know that the software is what sequential, right? If you write any software code, it's sequential, right? So one line after you run this line, go to this line, go to this line. So once you put any code within that loop function, it will run and get to the end and then start again, and it's going forever. You know that's the main difference between a software code and a hardware code. You guys know that, right? In case you are writing hardware code, so that is always that is when people start writing hardware code, that's always their issue. Because they always think like software engineers. Software engineering, your code is running one line at a time. In hardware, everything runs at the same time. So that makes hardware coding very, very difficult. Right? And then as you guys are computer engineers there. Alright, so we are all we are doing is blinking this thing, right? And then as I said, everything is about libraries, right? So the first line of code is, have you seen this one? Digital write. It's just a library of code, right? And then the digital write takes in two values. So it means that you want to write some value to a pin on the board, right? Have you seen the two values? So this value is the built-in LED, and then it takes the value high or low. The high means that you have applied some voltage to it, probably 3.3 volts, right? The low means what? 0 volts. As easy as that. Now, after we have applied a high, there's another function known as delay. The delay takes in only one variable, which is the time in milliseconds. So if you see so anything you put within the delay function is in milliseconds, right? So if you put in 1,000, what does that mean? How many seconds is it? Don't even try to calculate. But 1 second, right? If you put in 2,500, what is it? this thing, you don't have to think. If you start, oh, and then also in the exam, if you begin to think, it means that you are wrong. Don't just answer. Once you begin to think, once your brain begin to work, once you see the question, it means that you're already wrong. Because it's that easy, right? Okay, so now it means that you turn the LED on for 1 second, then you turn the LED off for what? 1 second, and then you loop. So that's how it turns on 1 second, turns off 1 second. Any question? Any question?